So this one, they're giving us the graph. And we're going to use the same graph on a couple of problems. And notice it is the graph of the derivative. So that's where I'm starting as the derivative. And we're wanting to find in this one where f is increasing and decreasing and relative maxes and mins. So because increasing and decreasing and relative maxes and mins come from the first derivative, these are things that match. And when it matches, we look for zeros on the graph, and we look at above and below on the graph when we are trying to draw our sign chart. So let's start our sign chart off here. So I've got my intervals. I'm going to assume it starts at negative infinity since it kind of is going off in all places. So I'm going to go negative infinity. I'm looking for where I have zeros. So my first zero is at 0. My next 0 is at 4. My next 0 is at 5, 6, 7, 8. And then it goes 8 to infinity. All right, so I need to look what is going on with my derivative. So I'm looking at above, below. So this first interval is below, so negative. My next interval is above, so positive. My next interval is below, so negative. And my last interval is above, so positive. So what does that mean about the original function? So in the original function, if my first derivative is negative, my original is decreasing. My first derivative is positive, my original is increasing. My first derivative is negative, original is decreasing. First derivative positive, original is increasing. And then, so let's go ahead and write out our answer. So f is increasing on, so the interval 0 to 4 and 8 to infinity, because f prime is, sorry, not is, I could just go greater than 0 at these values. Or, sorry, not at these values, on these intervals. On these intervals. And then we'd say f is decreasing on negative infinity to 0 and 4 to 8, because f prime is less than 0 on these intervals. All right, then we got to find the relative maximums or minimums. So I'm going to use the same sign chart, and this is kind of where I draw some little stuff at the end. So I'm going decreasing to increasing, increasing, decreasing, decreasing to increasing. So you can see these low points, those are your mins, and this high point is the max. So we're going to say we have f has a relative min at x equals 0 and 8, because f prime changes from negative to positive at these values. And f has a relative max at x equals 4, because f prime changes from positive to negative at these values. Likely on the test, I might not ask for both increasing and decreasing on the same question. I might ask increasing and maybe for the minimums or something like that. All right, so now we're using the same picture, but now we're looking at the concavity and the points of inflection. So this is the second derivative for concavity and points of inflection. So given f, I have to go to f prime. They mismatch. So when you mismatch, you look on the graph, you look at horizontal tangents, and then you look at increasing, decreasing to draw your sign chart. So let's start with our intervals. So I'm starting at negative infinity. My first horizontal tangent, I don't know, looks like about 2. Then my next horizontal tangent looks like it's at about 7. And that's it. So it goes to infinity. All right, so I am looking at what's going on with f double prime. So first it looks like I am increasing, so it'd be positive. Then it looks like I am decreasing, so it'd be negative. And then it looks like I'm increasing, so it'd be positive. So in the original function, that means that when it's positive in the second derivative, in the original it's concave up. When it's negative in the second derivative, that means it's concave down. This last one would be concave up. And then as long as the sign is changing, we have points of inflection. So let's write that in a justification. So f is concave up on, and remember, these are always open intervals, negative infinity to 2 and 7 to infinity, because f double prime is greater than 0 on these intervals. Oops, sorry. And then f is concave down on 2 to 7, because f double prime of 0, or f double prime is less than 0 on these intervals. All right, and then points of inflection would just be the 2 and the 7. So f has points of inflection at x equals 2 and 7, because f double prime changes sign at these values. Okay, so here's where you're going to get a little bit of a bonus for actually watching the video. There's probably going to be a bonus question on the test this time, and it's going to be something along these lines. So this is the same thing, but we're going to do a double sign chart on it. So I'm going to redo the sign chart. And for when I have to find increasing from first derivative and concave down from second derivative, I'm going to do, on my sign chart, I'm going to put all of the critical points. So I'm going to put both the zeros and the horizontal tangents on the same sign chart. Okay. So my first, I'm going to go negative infinity, and then my first one is 0. And then I think we had decided 2. And then 4. And the next one we said I think was about 7. And then 5, 6, 7, 8. I think this was supposed to be at 6, and I think I did 7 last time. So that next one is at 8. And then we'll go to infinity. All right. So I need to talk about what's going on with my first derivative and my second derivative. So for first derivative, I am looking at above and below. So negative infinity to 0, I am below. 0 to 2, I'm above. 2 to 4, still above. 4 to 6, below. 6 to 8, still below. And 8 to 10, above. Then I'm looking at the second derivative. So I am looking from negative 8. So this, now I have to look at increasing, decreasing. So from negative infinity to 0, I am increasing, so it's positive. 0 to 2, still increasing. 2 to 4, decreasing. 4 to 6, still decreasing. 6 to 8, increasing. And then 8 to infinity also increasing. So I am supposed to be looking for where it's increasing, so I need a positive f prime, and concave down, so a negative f double prime. So positive f prime and negative f double prime. So that only happens right there in that one spot. So you would say that it is from 2 to 4 is the interval that happens on. All right, so these are the exact same type of questions as we just did, only now we have to do the derivative of the equation by